Hello everyone, welcome to Sangam Tutorials SP Gubbi online classes for NCERT 10th standard for mathematics and science. So in the last session of physics, that is science, we had been solving problems on convex lenses and concave lenses. So numericals, 4 numericals were covered. So in this session also we will be going with some more unique problems on numericals, which are very important, which are taken from the previous year's examination papers of Cbse and NCERT, that is state syllabus. So before entering into the class, I just want to recall the things once again. Minus 1 by u plus 1 by v is equal to 1 by f. This is the lens maker's formula. So yesterday you have learned how to apply that and to find out the unknown values. And when we come to the magnification, magnification is v by u, and the relation between magnification again is, that is m is equal to h dash by h. So therefore v by u is equal to h dash by h. So these are the relations. And apart from that, the focal length of a convex lens is always negative. The focal length of a concave lens is focal length of a convex lens is positive because we measure it from the optic center to the principal focus. So once again, focal length of a convex lens is positive, focal length of concave lens is negative. And then when we come to magnification, so here in case of magnification, if the image is real and inverted, then we say that magnification is negative. If the image is virtual and erect, then we say that the magnification is positive, right? So these are the things very much required, theoretical part as well as the formulas required for solving numericals on lenses, right? I hope you enjoyed the last session. So in this session also you are going to get a good grip. Your grip is going to become still more harder on the problems. So I have sent you the science notes in the WhatsApp group. I hope you have updated with the notes, and today I am going to send you again some more numericals through WhatsApp for your practice, which are taken from the previous year's Cbse papers. Right, we'll go with the first problem today. A concave lens has focal length of 20 centimeters. So concave lens, it is something like this. Concave, convex is something like this, concave is something like this, which is totally different from a convex lens. So let us take a concave lens here. This is the concave lens. So I hope you remember, this is the optic center, this is the principal focus f1, this is f2. So for concave lenses we are going to get only one ray diagram. I hope you remember this. There are 2 ray diagrams, and out of 2, one is the light rays are traveling and falling on the lens, which are traveling from infinity, and they are getting diverged and they appear to meet as though they are starting from this point. That's the first ray diagram. And the second one is very important. We can keep the object in between the optic center and infinity, anywhere in between optic center and infinity, then you are going to get the second ray diagram. So based on that one particular ray diagram, we have designed this problem here, right? So a concave lens has focal length of 20 centimeters. So focal length from here to here, it is 20 centimeters. So this is the focal length. So I will write down the data along with that. So focal length is equal to f is equal to 20 centimeters. So shall I take it positive? Shall I take it negative? So here, whatever we measure it from the optic center of the lens, and if you are measuring along the direction of the incident light rays, then it should be taken as positive, and if you are measuring something against the direction of the incident light rays, then it should be taken as negative. So therefore, focal length, as it is measured from the optic center to the principal focus, so this length, as we are measuring in this direction, that is opposite to the incident light rays, therefore it should be taken as negative. So sign convections plays a very important role while solving numericals. You have to be very careful. Okay. So a concave lens has focal length of 20 centimeters done. At what distance from the lens? At what distance from the lens? From the lens, at what distance? A 5 centimeter tall object be placed. So object is usually placed on the left side of the lens. So you are going to keep the object here. So the height of the object is 5 centimeters. So object height is equal to h is equal to 5 centimeters. So shall I take it as plus 5 centimeters or minus 5 centimeters? It should be taken as plus 5 centimeters because here anything what we measure above the principal axis is taken as positive. So therefore h is equal to plus 5 centimeters. Now at what distance from the lens a 5 centimeter tall object be placed? So we do not know this distance. From the optic center of the lens, at what distance the object should be placed? So that is, he is asking you the object distance. So that is u. Object distance. Object distance is equal to u is equal to question mark. Don't write any negative sign or plus sign for the unknown variable where you have to still find it out. So don't put any sign for that is, don't put minus u, don't put plus u, don't put anything. Just u is equal to question mark. Okay. At what 5 centimeter tall object be placed so that it forms an image at 15 centimeter from the lens. So the object is formed at 15 centimeter from the lens. So this is focal length is 20 centimeters. So 15 centimeter is somewhere here. So this is the image which is formed here. Okay, this length, that is image distance, is 15 centimeters. Okay, so this is the image distance. Image distance, that is 15 centimeters. We will write that image distance. Image distance is equal to V is equal to, it is 15 centimeters. Shall I write it is positive or negative? Which sign we should put there? So again here we are measuring this 15 centimeters from the optic center towards the image. So therefore as we are measuring this along that is opposite to the direction of the incident light rays, therefore it should be taken as negative. So very simple, whatever you measure the distance if you measure it along the direction of the incident light rays, then it is taken as positive. If you measure it against the direction of the incident light rays, then it should be taken as positive. Along the direction, positive. Against the direction, negative. Very simple. Okay. So V is 15 centimeters. Now from the lens, calculate the size of the image formed. So that is if this is h and this will be h dash, you have to find out the value of h dash here. So we have to find out the object height. Object height is equal to h dash is equal to question mark. Don't put any sign for the unknown, which is plus or minus, whatever it is, we will get it in the answer itself, which is obtained by using the lens formula or the relation between V by U and h dash by h. Okay. So now, first of all we'll have to find out the object distance. We need the object distance here because we have focal length, we have the image distance. So as we have focal length and image distance, we can easily find out the object distance, and using V by U is equal to h dash by h, we can reach to h dash. Very simple, right? So we'll go get into a formula. So by lens formula, minus 1 by U plus 1 by V is equal to 1 by F. So we'll put the values. Minus sign I have maintained here. So 1 by U. U still we have to find it out. So no need to keep it inside brackets. Minus 1 by U plus V. V is negative. So it is kept inside brackets. That is plus of minus 1 by, that is plus of 1 by minus 15 is equal to 1 by focal length is 20, that is minus 20. So this is the substitution step, this is the formula step, this is substitution step. Okay. So minus 1 by U, right, we'll multiply this plus into minus, it is minus 1 by 15 is equal to, this sign can be taken to the numerator, that is minus 1 by 20. So minus 1 by U is equal to minus 1 by 20 minus 1 by 15, let it get transposed to the RHS, so then it is going to become plus 1 by 15. So minus 1 by u is equal to, for 20 and 15 LCM is maybe 60, we will check out. 15 and 20 LCM we will take. So 5 3s are 15, 5 4s are, so 3 1s are 4 and 4 one time, okay. 5 3s are 15, 15 4s are is 60, okay. So LCM is 60 here. So minus 1 by 20 into 60. So 21 times 23 times 3 into minus 1 is minus 3 plus 1 by 15 into 60 is 4. So minus 1 by u is equal to minus 3 plus 4 is 1 by 60. So when you take the reciprocals for both sides, so you get minus u is equal to 60. When you multiply both sides by negative sign, you are going to get u is equal to minus 60 centimeters. So what is the answer now? So here, what the object we had kept here, that is at a certain distance from the concave lens, what the object we had kept, so that object has to be kept at a distance of 60 centimeters from the optic center of the lens. So that is, we have got the answer. At what distance from the lens A 5 centimeter tall object be placed? So that's the answer. So here we have to keep the object. Our object is kept at a distance of 60 centimeters from lens. Right. Okay, this is the first answer we have got. So let us get into the second answer here. Calculate the size of the image formed. That is, you have to find out h dash. So we have u, just now we have find it out. We have v, we have h, and we have to find out h dash. So by using the relation we can do this. So u by v is equal to h dash by h. So u value is minus 60 by v value. V value is minus 15 is equal to h dash. H dash value we have to find it out by h. H is 5. So minus and minus cancels. So it is 5 1 times, 5 3 times, you can divide this. 3 1 times, 3 20 times, you can divide this. So h dash is equal to 20 centimeters. So what is the height of the object formed? The height of the object which is formed is 20 centimeters. So okay, the height of image is 20 centimeters. So why we are getting plus sign? Why we got 20 plus 20 there? Because plus 20 centimeter, that is the height of the image, indicates that the image is virtual and erect. So that is, the object, the image is placed above the principal axis. So therefore images, if you want you can write, therefore image is virtual and erect. Right, if the nature of the image is asked. Right, so this is the 3-mark question for you. So it was asked in 2011 Cbse final examination paper. Right. Okay, we will go with the second problem on lenses numericals. Right. So an object 50 centimeter tall. Imagine an object which is 50 centimeter tall is placed on the principal axis of a convex lens. So in every problem you have to check whether what type of lens is being used. So if you get what type of lens is being used, easily you can connect that to the ray diagram what you have practiced in the earlier sessions. So if you apply all the numericals to the ray diagrams, then you can easily reach to the solution. Right. So an object 50 centimeter tall is placed on the principal axis of a convex lens. Okay, let us take a convex lens here. So this is a convex lens. This is the principal axis, optic center f1, and this is 2f1. This is f2, and this is 2f2 for our reference. It's 20 centimeter tall. So here an object is placed 50 centimeter tall an object is already 50 centimeter tall is placed on the principal axis of a convex lens. So usually we place objects here on the principal axis like this. So this is 50 centimeter and this is h, what we call. Tall is placed on the principal axis of a convex lens. Its 20 centimeter tall image is formed on the screen placed at a distance of 10 centimeter from the lens. So 10 centimeter from the lens is on the other side of the lens, 10 centimeters, maybe we will take it somewhere here, 10 centimeters. So this distance is 10 centimeters, we will take, this is 10 centimeters distance, and the object is formed here. And the height of the object is given, it's formed on the screen placed at a distance of 10 centimeter from the lens. A 20 centimeter tall image is formed. So this is 20 centimeters. This is 20 centimeter and this is h dash, what we have taken. Okay. So I hope you got the picture now. So this is a convex lens. In front of the convex lens, we have placed an object which is 50 centimeter in height, and the image of this object is falling on the other side of the lens at a distance of 10 centimeters, and the height of the image is 20 centimeters. So here, this is the image distance, that is we have to take this as V. So V is the image distance that is given as 10 centimeters, h dash is the height of the image which is given as 20 centimeters, and this is the height of the object which is taken as 50 centimeters. So what we have to find out here is, from the lens, okay, find the focal length of the lens. So it's a very peculiar problem, very nice problem. In most of the problems what we have done, focal length, I hope this is the first time we are getting. Okay, let us go with the data and then we will go with the solution, right? So first we will write the object height. So object height is equal to, h is equal to 50 centimeter. So it is plus or minus. So it is compulsory, it should be taken as plus because it is measured above the principal axis. So h is plus 50 centimeters. Now image distance is equal to V is equal to, this is V, which is equal to 10 centimeters. So here what we have to take, whether we have to take 10 as positive or negative. So look at the ray diagram and check out. So whatever we measure it from the optic center of the lens along the direction of the incident light rays. So this is the direction of incident light rays and we are measuring in the same direction. So therefore it should be taken as positive. So image distance is positive, right? So next we will go with image height or height of image. Image height is given as h dash, which is equal to 20 centimeters. So is this 20 centimeters taken positive or negative? So here the image distance as it is measured below the principal axis, therefore it should be taken as negative, right? So using this thing we have to find out the focal length. So focal length is equal to okay, f is equal to question mark, right? So can you guess the sign convection for focal length? What type of sign convection we are going to get? That is, the focal length is positive or it is negative. Maybe, I hope it is positive, right? Let's see that. Okay. So we are given h dash and v we are given, and they are asking you to find out the focal length. So what is to be done? Which particular formula we can use here? Which very simple formula we can use here? So better we can go with h dash by h is equal to v by u. We will use that. We will find out u, and then we will by using lens formula we will go with finding f. Right, that's the better option. So right. So h dash by h is equal to v by u. So h dash is minus 20 by h, that is 50 plus 50 is equal to v is 10 by u. So u into minus 20 is equal to, on cross multiplication, is equal to 50 into 10. So u is equal to 50 into 10 by minus 20. So 10 one times 10 minus 2 times. So minus 2 1 times, minus 2 minus 25 times. So u is equal to minus 25 centimeters. So what is the distance of the object? Distance of the object from the lens, it is minus 25 centimeters. Why we have got minus means because we are measuring the object that is from here to here against the direction of the incident light rays. Therefore we have got u as minus 25 centimeters, right? So next we will go find out the focal length by using lens formula. So by lens formula, minus 1 by u plus 1 by v is equal to 1 by f. Okay, so we will substitute the values. So minus 1 by u value is minus 25, right, plus or else you can keep this minus outside and open a bracket. By u value is minus 25, you can do this, plus 1 by v. V value is 10 centimeters. 10 is equal to 1 by f. Very simple, minus into minus is plus 1 by 25 plus 1 by 10 is equal to 1 by f. For 25 and 10 we have to take the LCM. So 25 and 10, take LCM, go with the 5. 5 5s are 25, 5 2s are 10, 2 1s are and 5 1s are. So 5 5s are 25, 25 into 2 is 50, right. So for 25 and 10, LCM is 50. So 1 by 25 into 50 is 2, plus 1 by 10 into 50 is 5, is equal to 1 by f. So 2 plus 5 is 7 by 50 is equal to 1 by f. So take reciprocals on both sides. So when we take reciprocal on both sides, so we get 50, or f is equal to 50 by 7. So f is equal to, when you divide this 50 by 7, 7 1s are 7, 7 7s are 49, 1 remains, 7 1s are 7, that is 10 remains, 7 1s are 7 and 3 remains, 7 4s are 28, so 4, so that is 7.14 centimeters. So what is the focal length of the lens? The focal length of the lens is 7.14 centimeters, right. So focal length is 7.14 centimeters. So it is an approximate value, right. So this is for 3 marks. Okay, let us get into the third problem, a very unique classical problem on numericals, right. So it's very nice, very important problem also. It was asked in 2014 Cbse final examination paper, right. A convex lens, so very important. You have to just first get the type of lens which is being used there. So it's a convex lens, right. So I will take a convex lens here for my reference. This is the optic center. Alright. A convex lens forms a real image. It is going to form a real image. So in the sense, first 5 ray diagrams. Among the first 5 ray diagrams, one of the ray diagram is going to fit here. So 6th ray diagram is for virtual and erect image. So it doesn't apply here. So a convex lens forms a real image 4 times magnified at a distance of 60 cm from the lens. So I hope the object is placed somewhere here. So when you compare the size of the image with the size of the object, the size of the image is 4 times magnified. So if it is 2 centimeters, then it is 2 into 4, that is 8 centimeters, something like that. That is how you have to take it. If this is 1 centimeter, then 1 into 4, this is 4 centimeter. If it is 4 centimeter, then 4 into 4, it is 16 centimeter. That is how you have to take it. So a convex lens forms a real image. This is the real image because it is inverted. Real image 4 times magnified at a distance of 60 centimeter from the lens. Okay. So this is the image distance, that is 60 centimeters. Okay. This is nothing but V, right? 4 times magnified at a distance of 60 centimeters from the lens. Calculate the focal length, very important, and power of the lens. Oh, nice connection, right? So let us go with the data. Alright, so this is not required for you in the examinations, just for your understanding I am doing all these things, right? So m is equal to 4, I am going to write the value. So a convex lens forms a real image 4 times magnified. 4 times magnified value is m is equal to 4. So now the question arises, is this m positive or negative? Very important, very important. If you take it, the sign just opposite to what is required, everything is gone. So think before applying sign to this. So here, what the image you are getting here is a real and inverted image. So for real and inverted images, for the lens which gives real and inverted images, magnification will be negative. So m is -4. Very important. So if you are wrong here, everything is wrong. So be careful. You should be good in theory as well as you should be good in the ray diagrams for solving numericals on lenses. I still repeat it again. So if you are not good in ray diagrams, please go to the previous sessions what we have done in the classes. Go to the sessions, see the ray diagrams, practice them, and then come back to numericals. Then you will get a hold. So m is equal to -4. Okay. Now the image is formed at a distance of 60 centimeters from the lens. So the light is traveling in this direction. You are measuring in this direction. So though both the that is the direction of the measurement and the direction of the incident light rays are both same. So therefore the value of image distance becomes positive. So image distance is equal to V is equal to 60 centimeters, and that will be positive, plus 60 centimeters. Now you have to find the focal length. Focal length is related with image distance and object distance. That is in lens formula. In lens formula, focal length is related to object distance and image distance. So therefore we have only image distance. Using m and image distance, magnification and image distance, we have to find out the object distance. Then we will apply the lens formula, right? That's the procedure. So m is equal to V by U, very simple formula. So m value is -4, we will substitute this, is equal to V value, we are ready with that, 60 by U by 1. So what value of U you are going to get? That is a negative value or a positive value. You should get a negative value of V, that is U. U should be negative here, right? So U into -4 is -4U is equal to 60. So U is equal to 60 by -4. So U is equal to 2 minus 2s and 2 30s. So -2 1s are -2 minus 15s. So -2 into -15 is plus 30. So that is okay, right? So U is equal to -15 centimeters. So what is the object distance? The object distance here is, it is -15 centimeters. U is equal to -15, we have got, right? So now we will first find out the focal length. So by lens formula, -1 by U plus 1 by V is equal to 1 by F. So minus of 1 by U stands for -15 plus 1 by V is plus 60 is equal to 1 by F. We have to find out the value of F. So minus into minus is plus, 1 by 15 plus 1 by 60 is equal to 1 by F. So we have to take the LCM for 15 and 60. 15 and 60, I will take the LCM. So 5 3s are 5 1s are 5, 5 2s are 10. Okay, 5 12s are 60. So again I will go with 3. 3 ones are 3 fours are, so again the 4. So 5 threes are 15, 15 fours are is 60. So 60 becomes the LCM. So 60, 1 by 15 into 60 is 4 plus 1 by 60 into 60 is 1 is equal to 1 by F. So 4 plus 1 is 5 by 60 is equal to 1 by F. So 5 ones are 5 12s are again it is 60. So therefore 1 by F is equal to 1 by 12. Right, so therefore when you take reciprocal on both sides, so F is equal to 12 centimeters. So focal length of the lens is 12 centimeters. So I will wipe out the LCM. Right, so F is 12 centimeters. So focal length is 12 centimeters. Right. So now we have got focal length as positive because principal focus will be here, and you are measuring this, that is from the optic center to the principal focus, that is called as focal length somewhere here. So therefore it is plus 12 centimeters. We have got the right answer. So now we will have to find out the power of the lens. So power of the lens is given by P is equal to, as this focal length is in centimeters, we have to convert that into meters. So therefore directly we will take this 100 by F. P is equal to 100 by F. So P is equal to 100 by F is 12. So P is equal to 2 6s, 2 50s, 2 3s, 2 25s. So that is 25 by 3. So when you divide 25 by 3, 3 8s are 24, 1 remains 0.3 3s are 9, so 1 remains, it's enough. So P is equal to 8.3 diopters. So what is the power of the lens? So it's approximately about 8.3 approximate diopters. So this is how we have to go with the problem. So it's very important. It is also being asked in one of the final examinations of Cbse science paper. Right. Okay, let us get into the fourth problem. Very important. Again on a divergent lens. Divergent lens, is it a convex lens or a concave lens? So convex lenses are always converging lenses, and concave lenses are always diverging lenses or divergent lens. Right. So I have a lens which is a diverging lens. A divergent lens has focal length of 20 centimeters. Right. So for your reference, I am going to draw a principal axis. Right. This is the principal axis. This is the optic center of the lens. A divergent lens has focal length of 20 centimeters. So as the light rays travel, fall on the lens and are going to get diverged, all the light rays appear to start from a point on the principal axis to the left side of the lens. So this becomes the principal focus, right? As a focal length of 20 centimeters, so the distance between the optic center and the principal focus is 20 centimeters. So this is 20 centimeters. So I will write on the data. So focal length is equal to F is equal to 20 centimeters. So whether 20 is positive or negative, we have to check out, because light rays are traveling in this direction and you are measuring in the opposite direction. So therefore focal length is negative. Right. At what distance should an object be placed? So where you have to place the object. So object is usually placed on the left side of the lens always. So at what distance should the object be placed so that the image is formed 10 centimeters from the lens? So at what distance? For example, let us take this as the object. Let AB be the object. So if you place AB here at this point, for example, if you take AB as an object and if you place it here, the image will be formed at 10 centimeters here, that is from the lens. Here the image will be formed, that is A dash, B dash, the image will be formed here. So now this A dash, B dash, what I am going to call here, it is the image. So why I have taken a rear, that is a virtual and direct image, because the concave lenses always make virtual and erect images. So this distance from the optic center, this is 10 centimeters and this is taken as V. So image distance will take, image distance is equal to V is equal to 10 centimeters. So is this 10 centimeters positive or negative? So here, as you are measuring from the optic center towards this direction against the direction of light rays, so therefore V is taken as negative, right? So using these two, what we have to find? You have to find the magnification produced by the lens. You have to find the magnification produced by the lens. So magnification is equal to M is equal to how much? So don't worry, M is positive or negative, okay, automatically the value for M it comes out, provided if you use correct sign conventions for the data what you are having, right? So you have to find the magnification. So here, in order to find the magnification, we have two formulas. One is equal to 1, M is equal to V by U, and M is H dash by H. So here we don't have H dash and we don't have H, so this formula cannot be used. So therefore, in order to find out the magnification, we have to use V by U. So V is given, but we don't have U. We do not have U. So, but focal length is there. So now, what is the relation between F, V and this U? So the relation between focal length, object distance and image distance is given by the lens formula. So take the help of lens formula. And find out the value of U. Find out the value of U, because you have F and V. As you have F and V, by applying lens formula, find out the value of U. As you find out the value of U, apply the formula M is equal to V by U and then find out the value of M. So this is how we have to reach M. So this problem I am leaving it to you as a homework. So I hope you understood what we are getting. So at last, M value, what you are going to get, that is whether it is positive or it is negative. So M value here we are going to get, very sure we are going to get positive, because the image is virtual and erect, right? So I hope you enjoyed the entire session of 4 problems on numericals. So here, by this session I would like to conclude the chapter called Light in Physics. So all the concepts of the light chapter is covered meticulously. I have done it. So everything is presented very scientifically. I hope you have practiced everything. Entire chapter, the test is will be conducted the coming Sunday. So Sunday morning, get ready for the test, right? So Monday I will be going with the orientation class for the test, what is written by you, right? So please practice all the ray diagrams, practice all the numericals, power of the lens, right? I hope you enjoyed the entire chapter. So it's just ABCD of light what you have learnt in your 10th standard class. Still, in the name of optics, in your PU classes, you are going to learn more and more about this light, right? So I hope you will achieve your goal. You will reach what the goal you have set by working hard and very smart, right? So stay home, stay safe, and please keep learning. Thank you.